Okay, so this is Wednesday's kickoff, so we can take a look at both the worksheet and the some ideas that we're going about. On the worksheet, this is problem number one. I figured I'd put it up. Problem number one is this one with the pipe and the weight. And so you've got some graph paper right there. If you want to, you can take two pieces of paper and just take one sheet of paper and crisscross it with the paper on top of it, and then you can look through the paper, and now you've got grids going both left and right and up and down if you're into sheet graph paper. You can do all this homework on a notepad, snap a shot of it, capture it, JPEG it, and then attach that. So you can do all your work on a notepad and never print this thing out if you want to. And so that might be the easiest way. It's up to you. So what I did was I saw that it had, on this one, it had weight and length. And so the length goes from 0 to 18. The weight goes up to 45. So I thought, I want to know what the weight is compared to the length. So I put the weight on this axis. I should probably label that as weight in pounds, and then I've got the length sitting down here across the bottom. So I put the grid on here first, and I said 0 to 18, so I picked 9 squares, and I went 0 to 45, which was 9 squares. You don't have to have the same scale on each axis, so I've got 0, 2, 4, 6, 8, 10, up to 18, and I got 5, 10, 15, 20, up to 45. Again, you don't want little squiggly lines. Then what you do is you put the dots on there. So you've got 1 foot is 2.5 pounds. Well, 2.5 is halfway here. 1 is right in the middle. So my first dot goes there. 2 feet is 5 pounds. So it goes right there. 3.5 feet, 8.75 is below 10, further than 7.5, halfway. 6 is 15. 12 feet is 30 pounds. Here it would be helpful to have graph paper. And 18 is 45. So when you take a look at that, you can connect the dots. You should get a kind of a straight edge or whatever. I'm just going to swath it. Here, I'm going to put that in a different color, blue. When you put the straight line in with your straight edge, you do not have to hit every dot. In fact, I typically take the dots and make them just a little bit off. But this is pretty darn linear. So the question you're supposed to answer is the relationship linear, directly proportional, or inversely proportional? This is directly proportional. The thing you guys say is, as one gets bigger, the other gets bigger. Well, linearly, it is proportional as you do that. If linear, what's the proportionality constant, or the slope? So the slope is, if you recall, rise over run. Change in the y over the change in the x. The two things you need to know for physics is how to find the slope and y equals mx plus b. And so changing slope, rise over run, you pick any two dots. Now really you're supposed to take the dots off the line, but these are so linear. I'm just going to take, it went up 45, and it was 0 and 45. So 45 minus 0 over 18 minus 0. This is going to be in pounds per foot. And 45/18. Let's see, we can divide both by 3. We get 15 over 6. We can divide both by 3 again. We get 5 halves, 2.5. The slope is 2.5 pounds per foot, which you can almost pick up by that very, very first dot of 1 foot, 2.5 pounds. 1 foot's 2.5 pounds. So then it says, is there anything else you can be said about the problem, i.e. what's the speed or whatever? This one, you've got the mass or the weight per length of that thing. That's what the slope represents. Whenever you divide one thing by another, the units of the one divided by the units of the other is what the thing is. So this thing has 2.5 pounds of weight per foot. If you did this the other way and had length on the y and weight on the other, it would tell you how long to cut it for the weight that you wanted to support. So you'd have feet per pound. There's nothing magic about that as you do it, but we could actually write an equation. This one would be, if we said y, the weight equals 2.5 times the length. That would be our equation. Weight, y, equals 2.5. This is our slope times the length. You pick the length, you know how much it weighs. So that's the first problem. You're just doing that for each of these. If it's an inverse relationship, don't do the y equals mx plus b thing. You're just going, it's inverse. They're inversely related as you do that. There's 6 of those, and then there's some others as we go. That's the first piece.